Okay, topic 1 test review. We're going to outline some notes or a review sheet to help you look back at. Lesson 1 was all about domain and range and specific values of functions. So first one, talking about domain, and that is our x values. Okay, when we're talking about domain and range, are we looking at the whole graph or are we looking at different parts? We're looking at the whole graph. So looking at the whole graph. Okay, another thing I want to point out with domain, usually when I'm talking about domain, I talk about lowest x value, lowest x to highest x. And then in other terms, that's left to right. Because remember, domain is x values which go left to right. Okay. With domain comes range. Since domain is x values, what is range? Y values. So range is our y values. Again, we are looking at the whole graph. We are looking at the whole graph. So, since it's y values, we're looking up and down. So we're seeing our lowest y to our highest y. And instead of left to right, we're thinking up and down. Yep, so lowest y is down, highest y is up. Again, we're going up and down. With domain and range, we started talking about x and y intercepts. So x-intercepts, what does it mean to be an x-intercept? Where it crosses the x-axis. So if I put that in a picture, here's my coordinate plane. The line or the x-intercept is where it crosses that x-axis. How do we write intercepts? As coordinates, right? So if I write that as a coordinate, okay, it's some number and then my y is 0. What? Yep, if you were looking at this picture, it would probably be like a negative to 0 if you were looking at that picture. So then, what's another intercept other than x? Y-intercept. Y-intercept, and that's where it crosses. The y-axis. Yep, where it crosses the y-axis. And then picture form, it would be here. And then when we're writing the coordinates, it would be 0 and some number. If I was looking at this picture, I would probably pick 0, 3. Okay? So talking about increasing and decreasing. When thinking about increasing and decreasing, what values are we looking at? X or Y values?
Both.
Kind of. So when you're reading a book, how do you read it?
Left to right.
Left to right, so we want the X values. Yep. X values. And this is for both of them. We're going to write it on both. X values, we read left to right. Read left to right. When talking about increasing and decreasing, are we looking at the whole graph or are we looking at separate parts? We're looking at parts as a whole graph. Does that make sense? Because is the whole graph increasing all the time? No, it starts changing, right? So that's why we look at different parts. So look at separate parts. These were the 6 topics that we talked about when we're looking at graphs. Do you guys have any questions over those 6? Okay. I want you to look at example 7. We're going to look at 2 different examples. Okay, so example 7 on page 54. Go try and find those 6 different things. So, the notes that we just took, domain is what? Domain is what? The x values, right? X values, we're looking left to right. In parentheses, what did we write down? Lowest x. So lowest x, we're looking this way, right? Lowest x, what is my lowest x value on this graph? It is -5. Good. So -5. And now I want my highest x, right? Which all the way over here, what does this arrow mean? Infinity. Yep. Good. So domain is done. With range, what values are we looking at? Y. What did we write in parentheses? Lowest y. What is my lowest y value on this graph? -4. It is -4. What is my highest y? 1. Good. Okay. X-intercepts. Where it crosses the x-axis. How many x-intercepts do I have? I do have 2. I have 1 here, and I have 1 here. What is that first one? 1, 0. Good. And then the other one is 3, 0. Why can I not write this as 1, 3?
Because that's not an intercept.
That's not an intercept, right? Yep, we have to write them as 2 separate intercepts. Okay. Y-intercepts, how many do I have? 1, and it crosses where?
0, -1.
0, -1. Okay. Increasing and decreasing. How do I read these?
As coordinates. Left to right.
There we go. Left to right, what values? X values. Okay. So, starting all the way at the left, do you agree this is my leftmost point?
Yes.
Okay, what am I doing first? Which is decreasing. What is my starting value? -5. And I'm decreasing all the way down to what values do I want? I want x values, so -3. Where I stop decreasing, I start increasing. So I'm increasing at -3 all the way to 2. Where I stop increasing, I start decreasing, and I decrease all the way to infinity. Yep.
Negative infinity?
Nope, because remember it's x values. So it's going this way in the x values. If we were talking y values, then it would be negative infinity since it was going down. Yep. Okay, let's talk about these. The first one is domain. Domain is what values? X values. So remember on our lowest x to our highest. What's my lowest x? Yep. -infinity. My highest x is positive infinity. So domain, we go from -infinity to positive infinity. Next is range. What values are range? Y. What's my lowest y?
0.
0. Why is it not 2?
That's the x.
Yep. So we want the y value, which is 0. What is my highest y value?
Positive infinity.
Yep. Good. Next one, x-intercept. How many x-intercepts do I have? 1. That's a y. 1, how do I write that?
2, 0.
2, 0. Y-intercept,
There's 1.
there's 1, and that would be written as
0,
0, 2. Good. 2 more things we got to look at.
Increase, decrease.
Increasing and decreasing. Do you agree you kind of look at these at the same time?
Yeah.
Yes, okay. Where do I start? Left or right? Left. So I'm here. What am I doing first? Decreasing. We start decreasing at -infinity, and we decrease all the way to 2. Why is it not 0?
Because it's the x.
We want the x value. So we decrease from -infinity to 2. Where I stop decreasing, I start increasing, and I increase from 2 all the way to infinity. Good. Now we're going to talk about finding x and y intercepts algebraically. Okay, so x and y-intercepts algebraically. Okay. I'm just going to do 2 examples with you on these. Okay. So, first example I want to do is f of x equals 3x plus 9. What should we do first? What can I turn that f of x to? A y. Yep. So this would be y equals 3x plus 9. So now we want to find the x and y intercepts of this function. So x-intercepts. What do I know about an x-intercept?
It's y.
What is the y? Y is 0, right? So our y value is 0. So we're going to listen to that. If y is 0, I'm going to plug in 0 for y. So this 0, I'm plugging in for y. So we have 0 equals,
3x plus 9.
yep. And now all we have to do is just solve for x. What's my first step?
Subtract 9.
Yep, subtract 9. So I have negative 9 equals
3x.
3x. Last step to solve,
Divide by 3.
divide by 3. So we have x equals negative 3. Now, is that how I write my answer?
No.
No, what do I want to write it as? Coordinates. So it would be my x is negative 3 and my y is 0. So there's my x-intercept. How do I find my y-intercept?
You plug x equals 0.
Yep, x would equal 0. So I'm plugging 0 in for x. So I have y equals, is it 30?
No.
Nope, 3 times 0 plus 9. What's 3 times 0?
0.
0 plus 9?
9.
9. How do I write my answer?
0, 9.
0, comma 9. And that is my y-intercept. So I have my x-intercept and I have my y-intercept. So my next example, B, it's going to be g of x equals x squared minus 16. What do I want to do first? Rewrite it. So I have y equals x squared minus 16. So we're going to find x and y intercepts. I'm going to find x first. What do I know about an x-intercept? Y equals 0. So I'm going to listen to that. I'm going to plug 0 in for y. So I have 0 equals x squared minus 16. What do I do from here? Add 16. So 16 equals x squared. What is the opposite of a square? Square root. Now, what I have to remember, if I take the square root, how many answers am I going to have?
2.
I'm going to have 2. It's going to be, yep, positive and negative 4. So how many x-intercepts am I going to have?
2.
2. What's one of them?
4, 0.
4, 0, and
Negative 4, 0.
negative 4, 0. So remember, when you take a square root, you're going to have 2 answers. Am I done? No, what do we have to find next?
Y.
Y-intercept.
Plug 0 for x.
Yep, x is 0 this time. So listen to what you just said. If x is 0, I'm plugging 0 in for x. So I have y equals 0 squared minus 16. What's 0 squared? 0 minus 16. Negative 16. How do I write that?
0, negative 16.
Good. Nice job. Moving on to lesson 2. This is where we talked about functions moving and how they move from the parent function. Okay, so let's talk about the parent function first. What do we know about the parent function?
It's always 0.
It starts at 0, 0. Yep. Yep, starts at 0, 0 or the origin. Okay. From there, from our parent function, When we start adding numbers into our equations, it's telling us specifically where and how to move. Okay, so we call those transformations. I'm going to throw a specific example in there to help us understand this. Okay, so the example I want us to write down is f of x equals x plus 7 squared minus 3. Okay, if I was talking about the parent function to this, it would be f of x equals x squared. Okay, looking at this transformation, how many different ways are we moving? 2, right? Because this plus 7 tells me something, and this minus 3 tells me something. Okay, now let's take some notes. The 2 different ways we can move is x and y. Do you agree? Okay, so if it's the x, how do I know if the x is moving? How do I know which one the x is?
7. It's in the first.
The one in parentheses.
It's the one with the x. Yep, x is with the x. And when we're talking about the x, what do we have to think?
Opposite.
We have to think opposite. So specifically with this example, if it says plus 7,
Left 7.
yep, so plus 7, that means left 7. Okay, and then talking about the y's, how do you know which one the y is?
It's by itself.
It's not with the x.
So is it by itself then?
Yep. Okay, with the y's, how do we think? Think normal. Yep. Go make another note on your x's. Okay, the x's are left and right, and the y's are up and down. Okay, so with the y, we have this minus 3. What does that tell us?
Down 3.
Yep, think normally. So we go down 3. Okay, that was all lesson 2 was about. Okay,
That was with the x.
okay. Looking at A, let's understand from the parent function, how many ways are we moving? How many different numbers are in this function right now?
2.
Careful.
Well, isn't there one in front of the x?
Technically there's one here, but that one doesn't matter with us.
Oh, then just 1.
Yep, just one, right? So we only care about this minus 7. Now we have to decide, is that an x value or is that a y value?
Y.
It's a y value. Why?
It's not with the x.
Because it's not with the x. It's not inside the absolute values there. Okay? So we can think opposite or think normal?
Well,
Normal. So minus 7 is telling me down 7. Now, if there was an x in there, it would look something like this. Okay, that would be with the x. Now, let's just do a review. That minus 2 is telling me what?
Go down 2.
Careful, it's with the x.
Right 2.
Right 2. Yep. Okay, talking about B, how many numbers or how many movements are there on B?
2. 1.
There's only one number, right? One number, that tells me there's one movement. Now, is it with the x or without the x?
not the x.
Without the x, so we can think normal. What is it?
Up 5.
Up 5. Yep. Good. Okay, lesson 3 was all about our piecewise functions. How many functions are in a piecewise function? At least
2.
2. Yep. At least 2 functions. Okay. I'm going to throw in a specific example. So if I have f of x, remember these piecewise functions, we're in our set notation. Okay. So for an example, I'm going to throw this in there. Okay, there is my piecewise function. Okay, couple questions I want to outline here. Question 1, how many functions are there? There is 3. Remember, it's just how many lines there are. 1, 2, and 3. So there are 3 functions in this piecewise function. Okay. So number 2 is, what can you tell me about the value x equals 2? Okay, show me on your hand if you think 2 falls in the second function or if it falls in the third function. Which function does 2 fall into? The second or the third? Or if you think both. Okay. 2, do you agree? Remember when it asked you about an x value, we're looking at the intervals now. So is 2 between -4 and -1? No. Is 2 between 0 and 2?
Yep.
It's equal to, right? Okay. So do you agree that 2 falls into function 2?
Yep.
Yes. What about 3?
It's not equal to.
Right, it's not equal to in here. Okay, the big difference in this function, let me switch colors. Big difference in this function, it's equal to. In this function, it's not. Okay, so x equals 2 falls in the second function. Now remember we talked about this. Second function, we got to talk about the second and third. Second function, it's equal to. The third function is not equal to. Now, on your test, it might show you a graph asking you the same question. How would you know on a graph if the second function was equal to or not equal to? Think about open and closed circles. So if the second function is equal to, that means it would have a closed circle. If it was not equal to, it would have a open circle. So that would be how you would tell if it gave you a graph. Okay. And what that could look like is if I had x equals 2. Say my 2 is here. If my second function was equal to and it looked like this, and my third function was not equal to and it looked like this. That was what it would look like if it was a graph. Okay, and then the first one would be here. Other questions you might get, okay, is what are different values? Okay, so if I asked you what's the value of x equals -2, what is the value if x equals 2, and what's the value if x equals 3, and the value of x equals 6. Okay, so it might ask you a bunch of different x values, but still looking at the same piecewise function that we have up at the top. Okay, if I'm looking at x equals -2, how do I determine what function it's in? I look at the intervals, right? To determine which function it's in, I'm looking at these 3 intervals. So I'm going to start at the top. Is -2 in between -4 and -1?
Yeah.
Yes, so if your answer is yes, that's the function that you're in. So if I plug -2 into that first function, what do I get out? 3, right? That's the only option. If I have 2 in here, the answer would be 3. So my x equals 2, the value would be 3. X equals -2, sorry. What about the value of x equals 2? Does it fall in the first function, yes or no?
No.
No. Does it fall in the second? Yes, because it's equal to, right? So it falls in this one. If I plug in 2 here,
-2.
my answer would be -2. Yep. Looking at C, x equals 3. Is it in the first function? Second function? Third function?
Yes.
Yes, so if I plug in 3 here, I have 3 minus 3 is... What's 3 minus 3? 0, yep. And if I write that off to the side, I'm plugging in 3, so that's where I get 0. Okay, and the second one I plugged in 2, so I got -2. What about this last one, x equals 6? None, right? 6 is not in any of these functions, so 6 does not have a value.